Hello everyone. Now it's time for the Barshad seminar. Okay, Barshad, please start your seminar.
Hello everyone, good evening. Today I am here delivering a speech on presentation on nuclear power.
Okay, fine.
Next, ma'am.
Okay, let's go with the next one.
Here is the contents of the presentation. Is history of nuclear power, nuclear fuel, nuclear fission, nuclear chain reaction, nuclear reactor, components of nuclear chain reactor, types of nuclear reactor, working principles, nuclear power in India, and the last one is conclusion of the seminar. Next, ma'am. History of nuclear power. Electricity was generated for the first time ever by a nuclear reactor on December 20, 1950. Electricity was generated for the first time ever by a nuclear reactor on December 20, 1951 at the ABR Experimental Station near Acro Lado in United States. On June 27, 1954, the world's first nuclear power plant to generate electricity for power grid started operations at Obansik, USSR. The world's first commercial scale of power station, Kaldahar Hall in England, opened in October 17, 1956. First nuclear power plant ever world. Nuclear fuel is any material that can be consumed to drive nuclear energy. The most common type of nuclear fuel is fissile elements that can be made to undergo nuclear fusion chain reactions in the nuclear reactor. The next, nuclear fusion. When a, when a neutron strikes an atom of uranium, the uranium splits into two lighter atoms and release heat simultaneously. Fusion of a heavy element is an exothermic reaction which can release large amount of energy both as electromagnetic radiation and as kinetic energy of the fragment. Nuclear chain reaction. A chain reaction refers to a process in which neutrons released in fission produce an additional fission in at least one further nucleus. This nucleus in turn produce neutrons, and the process operates if the process is controlled. It is used for nuclear power, or if uncontrolled, it is used for nuclear weapons. If each neutron releases two more neutrons, then the number of fissions doubles each generation. The components of a, go to next man, next slide. Here is the components of a reactor. The first one is controlled rods. Controlled rod made of a material that absorbs neutrons are inserted into the bundle using a mechanism that can rise or lower the controlled rods. The controlled rods essentially contain neutron observers like boron, cadmium, or indium. The second one is steam generation. Steam generators. Steam generators are heat exchangers used to convert water into steam from heat produced in a nuclear reactor. Either ordinary water or heavy water is used as the coolant. The third one is the steam turbine. A steam turbine is a mechanical device that extracts thermal energy from pressurized steam and converts it into useful mechanical. Various high performance allows and super allows have been used for steam generator tubing. The fourth one is coolant pump. The coolant pump pressurizes the coolant to pressurize of the order of a 155 bar. The pressure of the coolant loop is maintained almost constant with the help of the pump and pressurize the unit. Now the fifth one is the feed pump. The steam coming out of the turbine follows through the condenser for condensation and recalculate it for the next cycle of operation. The feed pump circulates the condensate water in the working fluid loop. The next one is the condenser. Condenser is a device or unit which is used to condense vapor into liquid. The objectives of the condenser are to reduce the turbine exhaust pressure, to increase the efficiency, and to recover high quality feed water in the form of condensate and feed back it into steam generator without any further treatment. A cooling tower is a specialized heat exchanger in which air and water are brought into direct contact with each other in order to reduce the water's temperature. As this occurs, a small volume of water is evaporated, reducing the temperature of the water being circulated through the tower. Here is a types of nuclear reactor. Reactor can be heterogeneous or homogeneous. A heterogeneous reactor has a large number of fuel rods with the coolant circulating around them and carrying away the heat released by a nuclear fission. In a homogeneous reactor, the fuel and moderate are mixed. For an example, a fusible salt of uranium like uranium sulfate or nitrate dissolved in the moderate like H2O. Here are some other types. Boiling water reactor or pressurized water reactor, pressurized heavy water reactor, high temperature gas cooled reactor, liquid metal uh, fast breeder reactor, yeah, show turbine generator plant common to all types. These are the all types of a turbine. Yeah, sorry, out of a reactor. Here is a diagram for your reference. Is a diagram of a reactor. Ma'am, how a reactor works in a nuclear power generator works. Here's a diagram for your reference only. Go to the next diagram, ma'am. Next slide. How a nuclear reactor works. 235 uranium fission by observing a neutron and producing 2 to 3 neutrons, which initiates on average one more fusion to make a controlled chain reaction. Normal water is used as a moderate to slow the neutrons, since slow neutrons take longer to pass by a uranium nucleus and have more time to be observed. The protons in the hydrogen in the water have the same mass as the neutrons and stop them by a billiard ball effect. The extra neutrons are taken up by a protons to form deuterons. 235 uranium is enriched from it is 0.7% in nature to about 3% to produce the reaction, and is contained in rods in the water boron control rods are inserted to observe neutrons. When it is time to shut down the reactor, uh, the hot water is boiled or sent through a heat exchanger to produce steam. The steam then the powers turbines. The next one is nuclear power in India. Nuclear power uh, is the fourth largest source of electricity in India after thermal. Hydroelectric and renewable source of electricity. As of 2017, India has 25 nuclear reactors in operation in 6 nuclear power plants, generating 4780 megawatt, while 5 other plants are under construction and are expected to generate an additional 3153 megawatt. India's nuclear power industry is undergoing rapid expansion with plans to increase nuclear power output to 64,000 megawatt by 2032. The country is involved in the development of nuclear fusion reactors through its participation in the ITER, International Thermoelectric Experimental Reactor project, and is a global leader in the development of thorium-based fast breeder reactors. Last one, the conclusion. Uh, while nuclear power cannot substitute fossil fuel entirely and become the sole sustainable energy resource, it can play a significant role in the decarbonizing the production of electricity. Nuclear power plant use nuclear fusion, the process of splitting an atom into two. The next one is a nuclear fusion, the process of combining atoms into one, has the potential to be safer but has not yet been developed to operate within a large power plant. Nuclear energy comes from uranium, a non-renewable resource that must be mined. Every 18 to 24 months, a power plant must shut down to remove its spent uranium fuel, which becomes radioactivity. Whereas nuclear power plants generate about 20% of electricity. Nuclear energy is being used in more than 30 countries as of now around the world. Thank you, ma'am.